Hello everyone, welcome back to our channel. Today, we are building a PulseWave monitoring system using ESP32, a KY039 pulse sensor, and an OLED display. This project can detect PulseWave signals from a fingertip and display the readings in real time on the OLED screen. For this project, we need an ESP32 development board, a KY039 pulse sensor, an OLED display, a breadboard, jumper wires, and a USB cable for programming and power. Before we begin the project, let's first make sure that our ESP32 board is working properly. Here, an LED is connected to GPIO32, also known as D32, through a 220 ohm resistor. The LED blink program has already been uploaded to the ESP32, so no additional programming is required at this stage. To perform the test, we simply power on the ESP32 board. Once power is supplied, the microcontroller starts executing the uploaded code automatically. As you can see, the LED connected to D32 is blinking continuously. The LED turns on for a short duration and then turns off repeatedly according to the programmed instructions. This simple test is commonly used to verify that the ESP32 is receiving power correctly, the microcontroller is functioning properly, and the previously uploaded code is running without any issues. Since the LED is blinking as expected, we can confirm that the ESP32 board is working successfully and is ready for the next stage of the project. First, place the ESP32. Connect the 3.3 volt pin of the ESP32 to the positive rail of the breadboard. Then connect the GND pin of the ESP32 to the negative rail of the breadboard. These power connections provide the required voltage to all the components connected to the breadboard. Once the power rails are ready, we can proceed with the sensor and display connections. Now let's connect the KY039 pulse sensor to the ESP32. This sensor is responsible for detecting the pulse wave from a fingertip using infrared light technology. First, identify the 3 pins of the KY039 sensor, signal, VCC, and GND. Connect the signal pin to GPIO34 of the ESP32. Next, connect the VCC pin to the positive rail of the breadboard and the GND pin to the negative rail. The working principle of this sensor is quite simple. The infrared LED emits light through the finger, and the phototransistor detects the amount of light passing through. As blood flows through the finger with each heartbeat, the amount of reflected and transmitted light changes slightly. These changes are converted into electrical signals by the sensor. The ESP32 reads these signals through GPIO34 and processes them to generate a pulse waveform. This waveform can then be displayed on the OLED screen for real-time monitoring. Now, let's set up the OLED display for our PulseWave monitoring system. First, take the OLED display module and carefully place it on the breadboard. Make sure all 4 pins are properly inserted and that the display is firmly secured. A stable placement helps prevent loose connections and ensures reliable operation throughout the project. Once the OLED display is mounted on the breadboard, we can begin the wiring process. The OLED display communicates with the ESP32 using the I2C communication protocol, which requires only 2 data lines. First, connect the SDA pin of the OLED display to GPIO21 of the ESP32. Next, connect the SCL pin to GPIO22 of the ESP32. These connections allow the ESP32 to send display data to the OLED module. Now, let's connect the power pins. Connect the GND pin of the OLED display to the negative rail of the breadboard, then connect the VCC pin of the OLED display to the positive rail of the breadboard, which is connected to the 3.3 volt output of the ESP32. This completes the power supply connections for the display. The OLED display is one of the most important parts of this project because it provides a clear visual representation of the pulse wave data. As the ESP32 receives signals from the KY039 pulse sensor, the processed information is instantly displayed on the OLED screen. This allows us to monitor the pulse waveform in real time and observe how the signal changes with each heartbeat. With the OLED display successfully placed and connected, our hardware setup is now almost complete, and we are ready to test the project and view the PulseWave output. Now, connect the ESP32 using a USB cable and upload the code. The system is now ready to monitor PulseWave signals. Now, place your finger or hand on the KY039 pulse sensor. The sensor detects changes in blood flow and sends the PulseWave data to the ESP32. This is the circuit diagram of our PulseWave monitoring system. The ESP32 acts as the main controller. The KY039 pulse sensor is connected to GPIO34 for pulse signal detection, while its VCC and GND pins are connected to the 3.3 volt and ground lines. The OLED display is connected through the I2C interface, with SDA connected to GPIO21 and SCL connected to GPIO22. The OLED and pulse sensor share the same power and ground connections from the ESP32. Together, these components work to detect and display PulseWave signals in real time. This completes our PulseWave monitoring system using ESP32, a KY039 pulse sensor, and an OLED display. The system successfully detects PulseWave signals and displays them in real time on the OLED screen. We hope this project helps you understand the basics of pulse sensing and ESP32 interfacing. Thank you for watching, and don't forget to like, share, and subscribe for more exciting electronics and robotics projects.